Welcome to BVR Physics and Chemistry Made Easy. Today our topic is about matter around us. So completely it is written on the board. Good explanation will be given. See, when you speak about matter, matter is classified into three types: solid, liquid and gas. You know the main reason for this classification? The main reason for the classification of matter into solid, liquid and gas is intermolecular distance. In solid, see, intermolecular distance means, suppose say these two are molecules. This is a molecule and this is a molecule. Now packed, both are very close to each other. So there is no gap between these two. That is called intermolecular distance. Distance between a molecule and a molecule. This distance is called intermolecular, molecule to molecule distance. Okay. So when you take solid, you see there is no intermolecular distance. There is no intermolecular distance. If there is no intermolecular distance, then force of attraction will be more. No intermolecular distance, so both are very close to each other, more force of attraction will be there. If the intermolecular distance is large, force of attraction is less. And the other way, I am taking a unit area, a particular unit area, okay, or else I am taking a volume, length into breadth into height, so I am taking a volume size. Now you see in that volume, so I have drawn three diagrams with the same volume. So you see more number of molecules here. So when you compare 3, here you find more number of molecules. And when you speak about liquid, it has less number of molecules with solid, but more number of molecules with gas. And gas has least number of molecules. Why? Because the intermolecular distance here is large. Now this is the area. So if the intermolecular distance, the distance between two molecules is more, then very few molecules will be found in that unit volume. So here what happened, the intermolecular distance is less. So within that unit volume, you find more number of molecules. If the number of molecules are more within a particular volume, then automatically its density will be more. Right? Same. So we will speak now one by one over here. What is the first one? IMD and F of ATT. That means what? I wrote short form. See here, IMD means intermolecular distance. IMD. And what is F of AT? That is force of attraction. I just wrote it in a short form. You need not remember it. You can simply remember it as intermolecular distance and force of attraction. Now see what is happening. If the intermolecular distance is more, the distance between two molecules, if it is more, that is we call it as intermolecular distance is more. If the intermolecular distance is more, where do you find this intermolecular distance more? Is it in solid or liquid or gas? It's in gas. See, I am showing you. The intermolecular distance here is large. Intermolecular distance. First try to understand the term. Distance between two molecules. Here it is large, more. Therefore, what happens? Force of attraction will be less. Quite natural, isn't it? If the molecules are tightly packed, then they will have force of attraction. Since here there is intermolecular distance and molecules are apart to a long distance, then automatically force of attraction will be less. Quite opposite, in the opposite direction. If the intermolecular distance is less, hello, it's in solid, intermolecular, the distance between two molecules is here, it is less, then automatically force of attraction will be more, because molecules are very close to each other, so more force of attraction will be there. So it's true, this is confirmed, right? Finish. Okay, first one. Now what is told here? Force of attraction is more. Now let us bring the same thing here. So force of attraction is more. Let us bring the same thing here. Very clear. If you can understand like this, it will be much more easier. Now force of attraction, we said intermolecular distance less, force of attraction is more. Force of attraction is more where? Solid. So let us bring the same thing here. Force of attraction is more. Then automatically its density also will be more. Why? because these two are directly proportional. You know the meaning of directly proportional? If this increases, this will also increase. You know the meaning of inversely proportional? If this increases, this will decrease. If this decreases, this will increase. Very good. So here, force of attraction is more, density is also more. Where do you find force of attraction more? You find force of attraction more in solid, because intermolecular distance here is less. So force of attraction is more. So force of attraction is more, its density is also more. See, if you consider each molecule as 1 kg, too many molecules here, too many molecules, that means automatically its density will be more. Now coming to this one, let me rub off all this in order to avoid confusion. Okay, done. Now what our intermolecular distance is inversely proportional to density. Why are we saying intermolecular distance inversely proportional to density? Because just now we are saying same intermolecular distance was inversely proportional to force of attraction, and this force of attraction is directly proportional to density. That means force of attraction and density both are friends. Force of attraction and density both are friends. Where do you find force of attraction? Here. In force of attraction is more for solid. Yes, force of attraction is more for solid because intermolecular distance is less. Force of attraction for solid, it is more than liquid, then more than gas. Same thing where do you find the same thing here? That means these two are friends. These two are friends. Now coming to next one here. Diffusion is inversely proportional to force of attraction. So where do you find more force of attraction? More force of attraction? Solid. So solid diffusion is less. Diffusion means what? For example, you find somebody has opened the perfume bottle's lid. What happened? Perfume spreads. Who will carry that perfume to the next person or all corner of the room? It is gas. It is not solid. Solid will not carry that one. It is gas which carries fast. Therefore, diffusion is more in gas. If you say diffusion is more in gas, suppose you are saying diffusion, you are speaking of diffusion, and diffusion is more, actually it is compared here. Diffusion is more in gas. So I am taking the same point here. If diffusion is more, if you say diffusion is more, then force of attraction should be less there. Exactly. Here the force of attraction is less. Why? Because it has more intermolecular distance. Again back. Gas is having more intermolecular distance. Molecular distance is more. The gap is more. The distance between two molecules is called intermolecular distance. This is large. Therefore, force of attraction is less. If force of attraction is less, that same thing you bring it here. Same thing you bring it here. Yes, force of attraction is less. That means diffusion will be more. Yeah, exactly. Yes, diffusion. Somebody is preparing biryani. We get the smell at several meters away from that source. Why? It is gas which carries. That means what happened? Diffusion of gases are more. Why? Because its force of attraction is less. What do you mean by force of attraction? Force of attraction is inversely proportional to intermolecular distance. Here. Right? This part is over. So, what do you notice here? Diffusion and intermolecular distance, and now we'll be coming up across compressibility. These three are friends. Again, friends. As I told you, our channel is to make science much more easier. We wrote these type of things. So force of attraction and density both are friends. And intermolecular distance, diffusion and compressibility are friends. That means what? Force of attraction and density has a common enemy. These things are common enemies. That means they are inversely proportional. Force of attraction, density is completely inversely proportional to intermolecular distance, diffusion and compressibility. Can you compress a solid? If I give you a small solid piece, can you compress it to a small size? No, it's not possible. So once again, the compressibility is what? very less in solid. Suppose say like this I want to compare, compressibility is less in solid. That means their intermolecular distance should also be less because these two are directly proportional. Yes, exactly. Intermolecular distance is less. Less. The distance between two molecules is less here. Less. That means compressibility is also less. Compressibility is directly proportional to intermolecular distance. Suppose as I just now told you, if I give you an iron piece, can you compress it? You cannot compress it. Why? Intermolecular distance is less. Compressibility in solid is less. You cannot compress solid. You cannot compress a solid. You cannot compress a solid. Cannot. Means compressibility here is less. Why? Because intermolecular distance is also less. The distance between two molecules is less. Such an easy thing it is. This chart will help you a lot. For the first lesson you will get a question. Compare the properties of solid, liquid and gas. What are the properties you are supposed to compare? It will be intermolecular distance, force of attraction, density, diffusion and compressibility. So we have given a great chart. So just now I told you your intermolecular distance, diffusion and compressibility are friends. So intermolecular distance, compressibility and yet diffusion. See, in all this 1, 2 and this third case, gas is more. Right? In between it is liquid, then it is solid. Same thing as I was just now telling you, force of attraction and density are friends. See, force of attraction, solid has more force of attraction, even density also is more. So it will be very helpful to you. Right? We'll take a photo of this chart that will also be displayed in the same video. Thank you. Subscribe my channel.